All right, we got a couple sections to do. Let's finish up chapter 6 here. We are at the halfway point. Today is day 8 out of 15. We had 7 days before us. There's 7 days after this. This is the halfway point. So today we're doing 6.3. This is on the Poisson distribution. Like toy, son is how it's pronounced. Like toy, but poi. The Poisson distribution. Like the binomial, there are some requirements. So the Poisson has 3 requirements. So number 1, or A, the probability of success, the probability of 2 or more successes in a small enough interval is 0. Morning, afternoon. I have no idea why that's not on. You see a power button on that while you're walking by the TV? It should be all hooked up. I never had to do anything before. Thank you.
Are we just doing 6.3 today?
No, we're doing 7.1, 7.2, chapter 7 as well. You wish. So, like, we can have this 1 success, but if we have 2 successes, there's 0 probability. Interval is like a range. So like sometimes this is time. So we can get like a small enough window of time that there's no way we can get 2. Like a phone call. You can't get 2 phone calls in 1 second. It's impossible. You can't answer the phone and hang up fast enough to get a second fucking ring in 1 second. So that's what it means by 2 or more successes in a small enough interval is 0. The probability of success is the same for any 2 intervals of equal length. And C, the number of successes is, or not is, in any 1 interval independent of the other intervals. So we really don't want any overlap. We don't want to go from like 11:58 to noon and then 11:59 to 12:01. That's got overlap. Then they are dependent. It should be stuck. No, see that?
Hey.
Hey. You're late.
Alright.
Just fucking around.
Maybe we have to change the channel on this again.
I don't know what the hell you hit.
I didn't do anything.
No, John Logan, where'd you see a fucking power button?
Hit the top on the left.
That's volume. I don't know which one it is. This is going to. Oh, it's not that one on HDMI. This one component. Maybe PCN. Maybe home network. I don't think it's that. I think it's actually asking for a direct flash drive.
Sure, it's not just like HDMI.
I'm gonna do it till I find it. Oh, you fucking kidding me? That's not what I want. Other than fuck. And I suggest if you want to watch what I'm doing, you move on that side of the room. I don't know what's wrong with this fucking thing. And I could sit there and waste 20 minutes and not get it working. This one works. I've already wasted enough time. That gave John Luke time to write it, though. That was worthwhile. All right, so the symbols that are in the formula that you need to, even in StatCrunch, you need to know. This is called lambda. It's a Greek letter. This represents the rate or average number of occurrences. T is the time interval. Time or whatever the interval is. But it's often time. And X is the number of successes. The formula is, in case you're feeling like, I know what the hell I'm doing, I'm gonna do it by hand. lambda times t raised to the x power over x factorial times e raised to the negative lambda t power. That's if you're a psychopath or you're doing some like advanced stats. What we're going to do is stats calculators and Poisson. Of course, that's in StatCrunch. Here's Scotland. That TV's down, so if you want to watch, you might want to be on the left or this side. It's doing its own thing. All right, so let's have an example. The FDA, our Food and Drug Administration here in the great nation of the United States, sets a food defect action level, abbreviated FDAL, for various substances that inevitably end up in our food supply, food and drinks. So like when they test, if higher than that amount of the substance shows up, they flag the food as defective. We are going to look at chocolate. Everyone like chocolate? If you don't, get out. Chocolate. And because I don't want you to take my word for it, when everyone's done writing, we're going to go over to the website for the FDA, and we're going to look up chocolate on their food defect action levels. They have a handbook. Everyone ready? So I got food defect action levels. This is the FDA's website, fda.gov. Let's just do a search for chocolate. Chocolate and liqueurs. Insect filth. Average is 60 or more insect fragments per 100 gram. Okay, so I'm gonna write that down. 60 or more fragments per 100 grams. If I wanted to write this as a rate, I would have 60 fragments over 100 grams, which gives me 0.6 fragments per gram. Now a fragment they've got like larvae, wings, you know, shit like that, legs, eggs, legs.
Chocolate.
They also had something in there for rodent filth as well. Rodent hairs and stuff.
Chocolate?
Chocolate, yeah.
Ooh.
Rodent hair was an average of 1 or more rodent hairs per 100 grams. If they checked 6 100-gram samples. So, we don't deal with grams a lot, so like, let's talk about like a Hershey bar. Your standard Hershey bar is 1.55 ounces. And that's approximately 43 grams. So when we go to StatCrunch, StatCrunch requires X and mu of X. Mu of X is lambda times T. Well, I have a rate. My rate is in fragments per gram. That's going to be my lambda. So this is lambda. And so if mu of X is lambda times T, what we're looking for is like the mean number of fragments. If I multiply by 0.6 fragments per 1 gram, whatever this is here has to be in grams so that I end up with just fragments. And so that's going to be our T. Our T is going to be like how much is in a Hershey bar. Our T is going to be 43 grams. So I'll put that here. And if you multiply 0.6 times 43, you're going to get 25.8. We're gonna look at some scenarios. Before I do, I'm gonna use up the rest of this page, just to like give you some boxed information. Mu of x, I already said was lambda t. The standard deviation is the square root of lambda t, which is just the square root of the mean. Those are what you need to, like the formulas you may need to know. You'll definitely need to know the mu of x for using StatCrunch.
When we're finding the mu of x for the 0.6 fragment in the 1 gram, is it like you put a 1 underneath the grams?
So the one is with the grams. It's like the 0.6 goes with the fragments per 1 gram. You don't really need the 1 there. I just wrote it to make it clear what's going on. We got it from the 60 over 100. And when you reduce this, it's 0.6 over 1.
So then it's just 43 times 0.06.
Yeah.
Okay.
Yeah, let me put that a little clearly. This was 43 times 0.6. Everyone ready? Okay, so we need that 25.8. I'm going to write it on the next page. So for our chocolate problem, the mu of x was 25.8 fragments. Let's look at, so this covers a full Hershey bar. What is the probability that x will be greater than or equal to 3? Now, let's just do equals to 3. I think greater than or equal to 3 is a little overwhelming at first. Let's just start with 3. This means 3 fragments in your chocolate bar. So that's exactly 3. Let's also take a look at fewer than 3 and at least 3. Fewer than 3 should be x is less than 3. And at least 3 should be x is greater than or equal to 3.
Thank you.
All right. Oh, wait, never mind. John Lucas, right. So Scotland. Are you guys looking? Okay. So let's take a look at this in StatCrunch. That's for you and you. Mateo and Gianluca, you don't have to share that way.
Sounds like a plasma cannon.
Stats, calculators, Poisson. It looks like the word poison, but there's two S's. It's some French guy. So we need the mean. The mean was 25.8. And we wanted the probability that this was exactly 3. That's really low. The probability of exactly 3 is really low. What about fewer than 3? I'm gonna write that down. Let me write down the value of that. It'll show up on the next page. I don't even know how many fucking zeros that is. 1, 2, 3, 4, 5, 6, 7 zeros. 0.0000002. That's a lot of fucking zeros. The chances are your chocolate bar is not gonna have 3 insect fragments. That's a good thing, right? You would think. You see that hump? Hump's not centered above 3. Let's look at less than. Oh, this is even worse. E to the negative 9 means the decimal's got to move left 3 or 9 times. This is going to have 8 zeros in front of it. This is going to be 0.000000002 again.
What? It says 2.244.
E to the negative 9, that's scientific notation. The negative 9 means move the decimal point left 9 times. And the first point, we'll put it in front of the 2. And then I need 8 more zeros in front of that to move the decimal point all the way. Maybe that's worth talking about in a second. Let me write that down. 2.241 e to the negative 9. We'll do that in a second. At least 3. Probability is 1. They don't even give me a fucking decimal. 1. So the chances of you having at least 3 fragments in your chocolate bar is 1. Well, that's not pleasing. What if we made it up to 10? What's the probability of having at least 10? 0.99986. 99.99% chance of having at least 10 insect parts in your chocolate bar. What about 20? When does this number get like smaller? 20 is 0.89656. This is 89.7%. There's an 89.7% chance that your chocolate bar will have at least 20 fragments of insects in it. That's kind of
Pure pretzel, I guess.
90% is pretty fucking high, isn't it? 89.7, that's we might as well be saying 90%, right? What about 25? When is it going like 25, it's down to 58.89, so 58.9%. And if we go like 30 is only 22.8%, more than 30. So the chances of having more than 30 is higher than 1 in 5. 1 in 5 would be 20%. So that means on average, every 5 Hershey bars you get, one of them has more than 30 insect parts in it. Bon appetit for the next time you have chocolate. Now, I don't know if you say this is lucky or unlucky. In a normal semester when it ain't fucking 310 degrees outside and we're not doing like it all in 4 weeks, I bring in chocolate like M&Ms twice, and we count them when we do color shit and stuff like that. And I usually do one like this right before I cover this topic, because doing like handing out M&Ms doing the colors, and having the students eat the chocolate right before I cover this topic usually gets some fucking faces that just make me laugh. Like, what the fuck? You knew what you were feeding us. You didn't get the chocolate because I didn't bring any. It's too fucking hot outside. Which is up to you to decide if that's good or bad. Okay? There's going to be a problem in the homework. I wanted to take a look at it with you. I think that it's going to be a little, it confuses a lot of students. So I'm going to go look at it and show you it, and we'll talk about how to go about doing it. It's in 6.3. It's question number 5. So I'm going to write down what mine says. I don't know if you can read that. That's pretty small font. Let me switch over to the document camera. Actually, before I do that one, let's talk about this. This is short notation for times 10 to the negative 9. And negative exponents, when you have this, move the decimal left. And positive exponents, move it right. Which means I've got 2.241, and I need to move it left 9 times. 1, 2, 3, 4, 5, 6, 7, 8. And every one I skip that doesn't have a number, I'm going to put a 0 in. So 0.000. I need to move it. I'm sorry, I didn't count right. 1, 2, 3, 4, 5, 6, 7. I need to go another one. 8. That's what this means. Your calculator will do it every once in a while. StatCrunch will have you when your probability is just so fucking low, it's astronomically low, like you're better off getting, or you're more likely to get struck by lightning kind of thing. That's some deep shit. Because fewer than 3, this was fewer than 3. You are more likely to get struck by lightning than get a fucking chocolate bar that has less than 3 fucking insect parts in it. Process that. That's some deep shit.
Why are there so many bugs in chocolate?
Because it's a process. It's a machine. It's a machine line. There's not like someone hand making it.
It's like mass
I
production.
think if it was being
Mass production. That's the word I'm looking for. Thank you. What's
If
there?
it were handmade, it'd be higher.
Well, it does get higher, but like we looked at 30% or 30 parts was still 22.8%. That was just the insects. Then there was rodent hairs and yeah, delightful. There is an FDAL problem in your homework set. I'll let you find what the food is. I don't want to ruin that for you. I want you to enjoy that when you get to the homework.
It's either hot dogs or chicken nuggets.
You'll see. It's something most people like, which is unfortunate. Just like chocolate. Most people like chocolate.
I know.
What?
I know.
Right? It's fucked up.
You like, if I didn't even know about that,
Like at my house, that I've been crazy.
I just blew your minds, didn't I?
nah, I don't want to eat chocolate.
You do not want to look up food defect action level.
You know how they make protein
You
powder?
will see a fucking entire handbook on foods.
You know how they make protein powder? They get mealworms and they grind them up like a
Well, that's protein right there, baby.
No, it's
I
So,
wouldn't eat worms for that though.
if you really want to ruin your fucking, like, appetite, maybe this is a good diet thing, like every time you want to go eat, you look up what you're about to eat on the food defect action level. Just type that in, food defect, Google that phrase, food defect action level. and then go to the one that says FDA.gov with a bunch of shit after it. That's your it'll be a handbook. It's a handbook. And then if you hit Control plus the F key on at least Windows products, yeah. This gives you the find function. I don't know what it is on Apple. It's probably Apple and F. It gives you find, gives you a window to type in what you're wanting to eat.
That will work for the diet.
Got a good chance.
Yes.
Sometimes it's like, like one of the things listed on the chocolate thing was shell. Sometimes they're produced in, I think it was, I assume nutshell. Oh, the cocoa bean, the shell of like the cocoa bean, I think. I don't know. It's some type of shell. I don't think it's like crab shell or some shit like that. There's no reason for that to be in there.
Yeah.
But they often do like nuts in the same place with chocolate, so it might be nutshell.
So what I hit menu?
What?
Menu?
I just, on the phone, I don't know how you fucking do a find function on the phone. You can just scroll down, just keep scrolling down until you find, they're in alphabetical order. You can ruin your day that way. So on 6.3, problem number 5 is on hurricanes. So I'm going to read you, I'm going to write down what my problem says. My problem says, for the past 100 years, no, I'm sorry, 111 years, a certain state, they don't want to tell us which state it is. I'm assuming a US state, but it may not even be that. Suffered 26 direct hits from a major hurricane. Major hurricane is category 3 to 5. Assume this was typical. And the number of hits per year follows a Poisson distribution.
Should I pull this up while we do it?
No. Because then you're going to do the problem, you're not going to take anything away from this. Right? You're not going to learn a goddamn thing. You're just going to mimic what I'm doing and you won't learn it.
It'll probably be different numbers.
Right, but this is just like view an example, but even better. The teacher showed you how to do it and describe it and shit. So no, don't do this on the computer while I'm doing it. You won't learn it. And if it shows up on the midterm, that's a bad beat on you. You don't want that. You want to know how to do it. So if you would like to finish writing this down, I'll pause. There's a little more that it says, but not a lot. I only had 3 potatoes for lunch today. That's quickly becoming very unappealing. Very, very unappealing. And you know what? You would think hot potatoes would be better. They're not. Like my wife put like some potatoes in the air fryer for me when I got home. Nothing on them. They cooked. It's like a baked potato. A baked potato with no fucking butter or sour cream on it. You know how dry a fucking baked potato is? As it cooled, it got a little bit better, like it absorbed moisture from the fucking air or something, I don't know. But like the first 10, 15 minutes, it was dry as fuck, and I'm eating it like hell slow.
You can't use like a butter
It defeats the purpose.
mix or something.
I could. It's gonna defeat part of the purpose. The idea is to make it as unenjoyable as possible. That way, I don't want to eat it, and I eat just enough to sustain my body energy. And which is not, I don't. I eat just enough to feel full, is a better way to say it. My body will burn more energy than me filling it up on potatoes, because I start eating super slow, and I fill it a hell of a lot quicker than if I'm eating like some fucking chicken tacos. I will put away chicken tacos like no one's business. I can eat like 2 or 3 times the weight in chicken tacos that I will in potatoes, because I'm eating, well, maybe not that, that's a lot. But definitely more, a lot more. Because like I'm enjoying it and I'm eating it faster than I'm giving my body time to say, you're done. Potatoes, I'm eating slow enough, it's like, nope, you don't need any more, and I'm like, good, because I don't want any more. This tastes like shit. Everyone got this written? Okay, so recall for stack crunch, we need X and we need mu of X. X is always going to be asking, like, X in this one is number of hits. I'll tell you that right now before I show you part A. So mu of X needs to have hits in it. This needs to be hits per something. Well, the only piece of information they gave us was 26 hits over the last 111 years. So I'm going to put that in a calculator, and I'm going to get the mean rate. Now, neat. I should have known that would do this. So mu of X equals 0.234234 dot dot dot. In Stack Crunch, don't stop at 2 or 3. Enter as many as you can. For accuracy. Okay, this problem is going to go on to ask you some other things. Like I haven't even asked anything yet. It doesn't ask you the mean. The first thing it asks you is, what is the probability that the state will not be hit by a direct hurricane of that strength It says major hurricane. That's probably the better way of saying it. Will not be hit by a major hurricane in a single year. Now remember how StatCrunch window looks. It's got a graph. It's got a spot for your mean. And it says probability X, and there's some shit going on there. So we have the mean. This will be that 0.234 repeating. That's my mean. What am I putting in for probability of X for this one? What does it mean that it will not be hit by a direct major hurricane? 0. This is the probability that X equals 0. You would be surprised how many students email me and ask me that question if I don't discuss this in class. It doesn't say 0, and so they're like, nope, I got nothing. So it was worth saying. At this point, you just plug it in. After this, they start asking, like, they ask like 1, 2, 3, 1 hurricane, 2 hurricane, 3 hurricane, etc. But they might even do it with 0. After, somewhere along the lines, they start asking, after you turn in the probability, they will ask you, is this unusual? What we consider unusual events happen less than 5% of the time. So what they're really asking you is the probability that X equals whatever number they say it is that less than 5%? And 5% as a decimal is 0.05. Start memorizing this shit. It shows up all the time. In fact, the very idea that we're going to do on our hypothesis testing next week, all of next week, pretty much boils around 5% is like the default setting. We can look at 1%, we can look at different percentages, but 5% is the default setting, what we look at. So it's an important number to pay attention to. Any questions? The problem does say to round to 4 decimal places on the answer. Don't round to 4 decimal places on the mean that you put in. If you put only 4 decimal places in here, your answer is not going to be correct to 4 decimal places. So put in as many as you can. Don't be lazy. It's really what it boils down to, because like you only got to hit a few more keys. It's not hard. That's it for 6.3. I'm going to stop this, and so we can start chapter 7.